Hi everyone, in this tutorial we will see how to interface the dot matrix displays with the 8051 microcontroller. It is actually the Atmel 89S52 microcontroller that we are using here. So as you can see here, we have a few dot matrix displays here. So the first one is the 5x8 dot matrix display, and this one is a 5x7 dot matrix display, and this one again is a 5x8 dot matrix display. So as you know, they come into different sizes and they come into different colors. Some of them have a single color, like this one has only the red color. This one is a bicolor dot matrix display and it has got the red LEDs and the green LEDs in it. And this one again is a unicolor LED and is having only the red color. Also you can see here that they have the different dot sizes. This one is having the dot size of 3 mm and these two are having the dot sizes of 5 mm. So let's look at the opposite or the back side of this dot matrix display. So as you can see that here we have a few pins. In this case we are having a total number of 14 pins, and these are for controlling the different rows and columns of this display. So since this is a 5x8 dot matrix display, it is having a total of 14 pins, 8 for controlling the rows and 5 for controlling the columns. But 2 pins are actually common, so that's why there is 14. One we can leave unconnected too. So how to identify that which pin number is the pin number 1 and which pin number is the last pin in case of this dot matrix displays. So in our case we will be using this small dot matrix display which is of 5x8 size. So it is numbered BM10458ND and it is made by the Bright LED Corporation. So let me show you the data sheet for this particular dot matrix display. So as you can see here, we are having the features of this display. You can see the dot size equal to 3 mm and other features also. So looking at the package dimensions, you can see clearly that here it is mentioned that at the lower left corner is the pin number 1 which is mentioned here. So moving from left to right, suppose this is the pin number 1, then this will be like from left to right, this will be the pin number 2, 3 and so on. And on the upper portion, starting from right to left, if this is the pin number 8, then this will be the pin number 9, this is the pin number 10 and so on up till 14 as in this case. So the pins increment from right to left in the upper portion and from left to right in the case of the lower pins. So you can see the other dimensions of this display. Some description is also given about it. So we are actually concerned with the internal circuit diagram which we require for driving this dot matrix display and for turning on the different rows and columns. So you can see here the rows and columns are mentioned, and this is the actual thing which we require. You can see that here are few rows and we have some columns, and as I mentioned earlier, pin number 4 and 11 are common, so one out of these can be left unconnected. So if we want to suppose turn on the row 1, so in that case we will put a logic high at the pin number 9 and we will be turning on all the columns, so we will be getting the first row glowing. So similarly, if we want to have some column, glowing, in that case we need to put all the rows at a logic high, and a particular column which we want to glow will be turned on, so we can see the particular column being glowing. So actually we use here the technique called the LED multiplexing, in which we use the technique of persistence of vision for controlling the designs or making particular designs. So let's have a look at the other features and characteristics of this display. So you can see the absolute maximum ratings, the forward current and the peak forward current, and you can see the optical and electrical characteristics. You need to keep in mind the amount of current that should flow through the dot so that you get proper intensity. So here we are having some graphs. Okay, so now let's go to the coding section, the embedded C code that we require in order to turn on the particular rows and columns. So as you can see here, I have made a few functions. You can make them as you wish, and you can see the whole program. You can find this code at 8051.in website, and you can see the program is quite bigger. So let me show you the basic technique how we will be driving the whole dot matrix display with the controller, and how we are going to use the transistors. So as you can see in here diagram, we are having this row 1 and we are having a PNP transistor for driving this row, and this one is BC557 and is of PNP type. And for driving the rows we will be using 8 PNP transistors. In this case, the collector of this particular transistor is connected to row 1 and the emitter goes to VCC, and the base is connected to the microcontroller pin via some resistance, because we need to control the amount of base current flow. Similarly, for driving a particular column, we are using the NPN transistors, and in this case it is BC547. In this case the emitter goes to the ground and the collector is connected to the particular column. So if we want to turn on the row 1, we put a logic here. Since it is a PNP type, so we put a logic 0 here and we put a logic 1 here, so this particular LED will glow. So if we put the logics 1 at all the columns, this whole row will be glowing. So similarly you can connect the other 7 transistors of the PNP type for controlling the rows, and you can connect the 4 NPN transistors to these columns and control the display. And keep in mind the amount of time delay. It should not be more than 1/16th of a second. I have kept it to 1/200th of a second. So talking about the hardware section, so let's see what is the hardware that we require. So since we are using 5x8 dot matrix display, so first of all you require a dot matrix display. So this is BM10458ND. After that you require a microcontroller. So in this case we are using the Atmel 89S52. Apart from that you require the transistors for controlling the rows and the columns. So it is BC547 and this one is the BC557. Apart from that you require some resistances for controlling the base currents, and also some resistances need to be connected to the LEDs so that we can control the current through them to a safe value. You require some relay mates and their bases so as to make proper connections. Then you require some wire for making the connections. Then you require the solder, and after that you require the soldering iron for doing the soldering. So I have actually prepared the hardware, so let me show you that. So you can see here that we have a 5x8 dot matrix display that I showed you, and we have a total of 13 transistors here. These are meant for controlling the rows, and these 5 are for controlling the columns, and the resistances, as you can see, are connected to their bases and they all go to the microcontroller pins. Here we have the 89S52 microcontroller from Atmel. So let me start the circuit and see whether if it works or not. So here we are having the source, and you can see that the circuit is working. So we are having some characters here. We are having some designs, some alphabets. So the circuit is working properly, and you can make one of your own. And thanks for watching.